In this example, I'll show you how to use the method of change of variable in a situation where it's not obvious that what we're looking at comes from the chain rule. Let's look at this particular integral, dx over x ln x. Now, the first question you might want to ask is, where is the inside? Okay, we don't have any brackets, we don't have any powers, so it doesn't look like it's a chain rule. Okay, however, right now we don't know how else to address or to approach this particular integral, so we're going to try and use this method of change of variable anyway. So what can we choose as the inside? Well, there is a denominator, and we may think of using something which is inside the denominator. The first thing that we can do is we can, for instance, pick x. X is a piece which is inside the denominator, and we could try to think of setting u equals x. But wait a minute, does that make any sense? Okay, what's the point of doing that? Now, this is believe it or not, this is a substitution, a change of variable that I see very often done by students. But when you think about it, this is just a change of symbol. All we're doing is we're changing the letter x with the letter u. Nothing else will change. Our integral will not look any different after we make that substitution, so please don't use it. However, we do have another piece that we might try to exploit, and that's the ln x. Well, let's try, see what happens. So we're going to let u equals ln x, and we're going to go through the moves. So that is, first of all, we're going to compute the differential. So that's du is equal to 1 over x, which is the derivative of ln x, times dx. Stop and think about whether that's actually a good idea. Are we on the right track? Well, let's keep going. Next step is figuring out what dx is. Dx is x du, of course. Alright, so let's make the change. Our integral therefore becomes the integral of the dx becomes x du. The denominator, the original x, we're going to leave it there, and then the ln x has become our u. If you're unsure about all these changes, just pause for a second and make sure that all the pieces are in there. But at this point, what we can do is cancel the x's. And what are we left with? So we're left with just the integral of du over u. Well, that's an easy one. We know what an antiderivative for that is. It's in fact the ln of the absolute value of u plus c. Alright, so that worked. All we had to do now is change back to the original variable. Remember, the original variable was x, so that means that we need to write it as ln of absolute value of ln x plus c. Now notice that the x inside does not need to be inside an absolute value because it's always going to be positive anyway. It was inside a logarithm. But there is another thing that we need to consider. Remember that the original function 1 over u has a discontinuity at 0. And that happens when x is equal to 1, right? Because the logarithm of 1 is 0. Therefore, a more proper way to write this antiderivative would have to be in two pieces. So ln of ln x plus c1 if x is less than 1, and ln of ln x of absolute value of ln x plus c2 if x is greater than 1. As usual, we're not going to put a lot of emphasis on this little technicality, but just a little reminder that it's there for us to consider if need be.